So given f of x, this is starter 2 for chapter 2.6, sorry. Given f of x equals x squared plus 3x minus 5, x is a member of the set of reals, find f inverse of x and state its domain. So, state its domain for f inverse of x. So we know that that's the range of f of x. So when we need this, we've tended to start by sketching. So let's sketch f of x. Well, we know we've got a positive quadratic. So in terms of the range, the turning point is going to be the key point. Need turning point. So let's complete the square on this. So f of x equals x plus 3 over 2 minus 3 over 2 squared minus 5. Sorry, there's a squared on there. So we've got x plus 3 over 2 squared minus 9 over 4 minus 20 over 4. So we've got x plus 3 over 2 squared minus 29 over 4. So our turning point here is going to be at negative 3 over 2, making this equal to 0, and then the y value is negative 29 over 4. Taking that coming from here. Okay, so we've got the domain of f inverse of x. Domain f inverse of x is x has got to be greater than negative 29 over 4. Because they were the outputs from the inverse, from the original function. Yeah, so if we chuck some axes on here quickly, here, this is negative 29 over 4, and we want this bit up here. Yeah, they're the outputs from the original function. Okay, we've also got to find f of x. So, f inverse of x. So we let y equals x squared plus 3x minus 5. So the inverse function, we interchange x and y. So x equals y squared plus 3y minus 5. And we've now got to make y the subject. So inverse function, swap or interchange x and y, because the outputs from the original function y are the inputs for the inverse function. We've just used that idea to get the domain of f inverse of x. But now we've got to make y the subject. And at the moment, y appears twice. Well, usually when y appears twice, we factorise it and to change it so that we can take y as a factor, etc., etc. But here, we've got 1 as a y squared term and 1 y as a linear term. So we can't just take y as a factor of those two terms. It won't work. So what can we do so that y only appears once? Well, there's a little clue just above, because we started up here with a quadratic, we completed the square, and x now only appears once, the variable. So now we're in exactly the same position. We've got a quadratic here, and we want the variable y to appear once. So let's complete the square. So we get y plus 3 over 2 squared minus 9 over 4 minus 5, which is y plus 3 over 2 squared minus 29 over 4. So now we can find y. Add the 29 over 4, so x plus 29 over 4 equals y plus 3 over 2 squared. Now we square root, so y plus 3 over 2 equals plus or minus the square root of x plus 29 over 4. So y equals minus 3 over 2 plus or minus the square root of x plus 29 over 4. And that has made y the subject, so our inverse function, f inverse of x, and we've got to go back to the notation we were given in the question, is negative 3 over 2 plus or minus the square root of x plus 29 over 4.